Good morning, students. Now we will see the simulation and analysis lab. Exercise 2, that is Trusses. Analyze the given truss model and find out the following using analysis after ANSYS 15.0 or 12.2, whichever is convenient to you and available to you. And this is the truss model. The distance between the two support is 16 meters and the height of the truss member is 4 meters. Modulus of elasticity is 210 gigapascals and the cross section of each member is 10 into 10 raw minus 4 meter square. For this problem, we will be solving it in ANSYS now. Clear start, new, do not read file. File change directory. Already I have created exercise number 2, another folder. And this reference structure, okay. Then preprocessor, element type, add the link, okay. Then material properties, material library, select unit, user unit, okay. And then I'm going for sections, link, add 10 e power minus 4, that is what the cross section which has been given here. I'm just giving it everything in meters, because all the values are in meters, so I'm going for meters. Material models, structure, linear, elastic, isotropic. 210 gigapascals, 210 e power 9 Newton per meter square. Poisson's ratio is 0.3 for steel material. You have to take it from the data handbook if it is not given. Save database. And then modeling, create key points in active coordinates. So I'm selecting the first point, apply an origin point. So I'm just selecting, just a minute. I'm selecting the second point with the diagram, what we got it. So according to this diagram in active coordinates, the first point I am selecting the default point. The second point is existing at a distance of 4 meter and 2 meter. X-axis 4 meter, Y-axis 2 meter. Apply. And then the third point is existing at a distance of 8 by 4. So 8 by 4. Apply. And then the fourth point is existing at a distance of 8 by 0. Apply. And then the fifth point is existing at a distance of 12 by 2. Apply. And the sixth point is existing at a distance of 16, 0. 16, 0. Apply. Okay, that's all. Now we have created everything. Now after creating the key points, I will be going for lines. And lines I am selecting in active coordinates. I am selecting as per the diagram. That's all. The same what we have got it in the question. The same way I have created the diagram. Okay. Now I will go for this supports here. Now in the meshing, since in the question they have not mentioned how many elements we have to divide it, so by default we will be selecting it as all the lines as a single element. Apply. Number of element division as 1 we are giving it. Okay. Then we will be selecting the mesh tool, mesh, apply. Now it has almost meshed everything. You can see plot, multi-plot. The meshing is over, save database. Now the preprocessor is over. We'll go for solution. Analysis type, new analysis. The analysis type, new analysis is starting by default, so we don't need to change it. Next, define nodes, apply structural, displacement, on nodes. Here the condition is there. when we are giving the displacement, actually the diagram shows it is supposed to be arrested only in the y direction. That's all. It's just like a roller support. But even if a roller support we are arresting only in y direction, we cannot give straight away only uy should be arrested. Then it will take it as the velocity will also be existing in all the directions. So it will be a problem to us. So we have to arrest all the velocities in x, y and z. And even in z direction also we are not allowing. Means z direction is the direction in front of you, means front and back. We don't allow it. So we should mention, we cannot just give it out or the question is given to you. We cannot just simply give it to the ANSYS. We have to give in detail the ANSYS. So I am just saying that uy, uz, velocity x, y, z all to be arrested means you are allowing that ux direction is allowed to go for expansion or something like that. For these two nodes we are talking about. We are not talking about any other nodes. Only the first and last we are talking about. We are not talking about other node points or other key points. So suppose instead of giving this for this particular problem, even if you give all degrees of freedom, all dyf, you will get the same displacement. The result will be the same because it will not have any other moments or anything like that. So we don't get much differences in maximum deflection. We will be getting the same. Okay. So, but this is the procedure what we are supposed to go for. That's what I am saying it here. Okay. Now it is saying a duplicate degree of freedom label velocity z was found on the D command. Means suppose if we give the velocity about velocity is supposed to be constrained, then it is saying there is no such moment has been given, coupled forces has been given. That's why it is saying it like this. So I have given all these things, then I will be going for force or moment on nodes. I am selecting these three nodes as per the diagram. Okay. So apply. Y direction minus 20,000 Newton. All the three loads are given. That's all. Now in the second phase solution, I am coming to the last step. Solve current LS. Okay. Solution is done. Now ANSYS has solved the problem. Plot, multi-plot. Plot controls, hard copy to file. I am saving it. Then I am going for general post processor. Plot results, deformed shape, deformed plus and deformed. And the maximum deflection I am getting it is 0.005705. Plot controls, hard copy to file. Okay. And one more thing is, if you want to see the animation, I can say animate the deformed shape. So it is deforming it here. So the deformed shape it is animating. Now again deformed plus undeformed. I am putting deformed results in the uy direction. Okay. Now I can show you how it is operating because of the forces. Okay. Okay. Next one, save database. I can say deformed plus undeformed. Contour plot, nodal solution, degree of solution, displacement vectors. So this is the total deformation which I am getting it here. Plot controls, hard copy to file. This is the total deformation. And suppose if I want only the x component of displacement, how it is. Plot controls, hard copy to file. And if it is y component of displacement alone, I need it. Okay. Plot controls, hard copy to file. If I am giving it as z component, you don't find any deflection in the z component, that direction. Means only it can show you the x direction and y direction deflections. There is no z direction deflection for these truss members. Okay. Next, to find out the stresses for an exam, element table, define table, add by sequence numbering, LS1 and 2, we can give it like this. and through which we can able to identify. Since it is a student session, it has some restriction, so we cannot get it here. And then regarding your reaction forces, so we can able to find out the total force summations in all the nodes. I can give it as result element distresses. In the distresses, we can find the nodal solutions completely, degree of solution, displacement vectors. Okay, you can save it as file, save as. Here, in this case, you can get the deflection in the UX as well as UI direction. So file, save as. In the exercise 2B, not 2B, exercise 2, I can save it as all deflections. Okay. Next one, the reaction solution. We can find it out the reaction solutions also. In the distresses, reaction solution, all items. So we can find what are all the reactions are existing at different modes. So we can able to find it out. And then, okay, that's all about how to find out the deflection, stresses, and reactions, and the truss members. So before leaving, you have to save everything.